Hello. Uh, Today I'm going to teach you how to draw the projections of a lamina which is resting on one of its corners on HP. So as I said earlier, the initial position is very crucial in this projection of planes or projection of solids. So how to draw the initial position of a lamina which is resting on its corner on HP? It is like this. Okay, so it is resting on one of its corners on HP. The surface is inclined to HP, and the next condition he may give you, the edge opposite to the corner may be inclined to VP like this, okay, or like this, or he can give you the median passing through the corner, okay, is inclined to VP. Okay, I'll tell you the lamina uh, in different positions how to draw the projections. First, what you have to know is that if it says in the problem that the lamina is resting on one of its corners on HP, then what you have to do, you have to first find the center of the lamina. How to find the center of the lamina? Draw the perpendicular bisectors of any two adjacent sides of the lamina. Okay, so if you consider this side, draw the perpendicular bisectors of this side, okay, and this side, any side, or this side you can take any two adjacent sides. You draw the perpendicular bisectors of any two adjacent sides. The point at which they intersect, that will be the center of the lamina. This will be the center of the lamina. Oh. Okay, so here this is O. Similarly, for if it is a pentagonal lamina, okay, so if it is a pentagonal lamina, bisect any two adjacent sides. One is, suppose one is this side, draw the perpendicular bisectors of this, okay, and perpendicular bisector of this side. You will get the point at which they intersect, that will be the center of the lamina. O. Okay, so in these problems what you have to do is you have to draw the initial position such that you have to imagine the lamina to be completely resting on HP like this, and then the line joining the center of the lamina and the corner, if suppose this is the corner on which it is resting on HP, so the line joining the center of the lamina and the corner on which the lamina is resting on HP, okay, this is the line, should be parallel to VP. It should be parallel to the vertical plane. Okay, so in this position you have to draw the initial top view and front view of the lamina. Okay, whether it is triangular lamina or it is a pentagonal lamina, okay, like this. If it is a pentagonal lamina, the line joining the corner, if this is the corner on which it is resting on HP, the line joining the corner and the center of the lamina, okay, should be parallel to VP. So this will be the position if it is a pentagonal lamina. If it is a square lamina, so what will be the center? If you draw the diagonals, the point at which these two diagonals meet, that will be the center of the lamina, square lamina. So this will be the center. Oh. Okay, so if it is a square lamina, if this is the corner on which it is resting on HP, then the line joining the corner and the center of the lamina must be parallel to VP. So in this position you have to draw the top view and front view. you have to imagine that lamina to be completely resting on HP such that the line joining the corner and the center, okay, must be parallel to VP, and the corner should be to your left. So this is how you have to draw the initial positions. Okay, so I'll just I have given this in the notes, but I'll draw it here so that you will understand better. So if it is a triangular lamina, okay, you have to, the initial position will be, the top view will be like this. So if this is the center of the lamina, the line joining the corner and the corner on which the lamina is resting on HP and the center is parallel to VP, or you can see if it is parallel to XY line, it means it is parallel to VP. Suppose this is A, B and C. A is the corner on which the lamina is resting on HP. So in the front view, what you see a line on the XY line because the lamina is resting on HP. Okay, you see a line like this on the XY line. So this will be the initial position of the triangular, equilateral triangular lamina. So if you want to draw the front view, you have to look at the top view from here. If you look from here, A and B are visible, C is invisible. So A dash, B dash is visible, C is an invisible point in the front. So this will be the initial position of a square lamina. Triangular lamina. So for a square lamina, this will be the initial position. Okay, so I'll draw the initial position of a square lamina. Here I can tell that most of the students draw a rhombus instead of a square. You have to take care that the edges are at 90 degrees to each other. So when you draw this square like this, if this is the center of the lamina, the line joining, if this is the corner on which it is resting on HP, the line joining the center and the corner on which it is resting on HP must be parallel to VP. So if this is A, B and C and D. So as I said, you have to be careful that these angles must be 90 degrees. All angles must be 90 degrees. Okay, usually the students make the mistake. That's why I'm stressing on this point. So if you draw the projections, to draw the front view, draw the projectors from A, B, C and D. B and D will be in the same straight line. Okay, so that until they touch the XY line. So this distance from here to here and here to here must be same. Then join these points, you will get the front view of the lamina. So the points which are visible here are A, B and C. D is hidden. So this will be A dash, B dash, C dash and D dash will be hidden. So this will be the initial position of a square lamina which is resting on its corner on HP. So if it is a pentagonal lamina, it must be like this. Okay, the line joining the corner and the center must be parallel to VP or parallel to the XY line. Okay, so I will draw the initial position here. So suppose this is the pentagonal lamina. Suppose this is the center. So the line joining the corner and the center must be parallel to the XY line or parallel to VP. Suppose this is A, B, C, D and E. So draw the front view. To draw the front view, draw the projectors from A, B and E will be in the same line, C and E will be in the same line. So join this. This will be the front view of a lamina which is resting on HP on one of its corners. This is the initial position. So this will be A dash, B dash, C dash. If you look from here, A, B and C are visible. Therefore, this in the front view, A dash, B dash and C dash. Next is D dash in brackets and E dash in brackets. So this will be the initial position of a pentagonal lamina which is resting on HP on one of its corners. Similarly for hexagonal lamina. Okay, so you please refer to the notes, my notes. I have given it there. Now we will solve one problem. Okay, the problem is we will take up the regular triangular lamina. Okay, in the problem he will say one type of problems will be the pentagonal triangular lamina is resting on a corner on HP. The surface is inclined to HP. Okay, and the edge opposite to the corner, this edge, is inclined to VP. So in this position it is perpendicular to VP. Okay, so the surface is inclined to HP, the edge opposite to the corner is inclined to VP. So I will rotate this lamina like this. Now it becomes, the edge opposite to the corner becomes inclined to VP. Okay, so this will be the one type of problems which we will get here. So I'll just show you how to get the solution for that. Okay, we'll assume that the surface of the lamina is inclined to HP at say 40 degrees, and the edge or side opposite to the corner on which it is resting on HP is inclined to VP at say 30 degrees. Okay, so how to draw the projections of the such a lamina? Okay, first we'll draw the XY line, then draw the initial position, okay, such that the line joining the center of the lamina and the corner on which it is resting on HP must be parallel to VP, this line. Okay, and this will be the top view. Imagine the lamina to be completely resting on HP. See, so the front view will be this. So A, the corner is A, the corner on which the lamina is resting on HP is A, so it must be to your left always. Please remember that. Okay, so the front view will be aligned on the XY line. So this is A dash. If you look from here, A and B are visible, therefore this is A dash and B dash. C is behind B if you look from here, so it is invisible, so C dash will be in brackets. Next, as I said, you have to, if the lamina is resting on HP, you have to fulfill the HP condition first. What is the HP condition? The surface is inclined to HP at 40 degrees. So the inclination with HP, as you know, it is always seen in the front view. So because the corner A is on HP, in the front view that corner will always be on the XY line. So this will be A dash. Now draw a line inclined at 40 degrees to HP or 40 degrees to the XY line. So what must be the length of this line? It must be equal to A dash and B dash. So measure A dash and B dash and mark it here. So this will be the new front view of the lamina, which is inclined to HP, which is resting on its corner on HP, and inclined, the surface is inclined to HP at 40 degrees. This will be B dash and C dash in brackets. Now project the top view. To project the top view, just draw the perpendicular projectors from here, from A, from the previous top view. Draw a horizontal projector. This will be new A. Then from B and C, draw the projector, vertical projector. This will be from the previous B, draw a horizontal projector. This will be new B, and from C, this will be new C. And join A, B and C. You can see that the size of the triangle has reduced because the surface is inclined to HP. So in the top view, the triangular, equilateral triangle lamina, the size is reduced. So this will be the HP condition. This is the HP condition, and this is the initial position. Next one, the VP condition. What is the VP condition? He says the edge opposite to the corner, okay, is inclined to VP at some angle, say 30 degrees. So VP condition is the edge opposite to the corner, that is edge BC, is inclined to VP at 30 degrees. So in this, what you do, you draw a line inclined to XY line at 30 degrees. You know the inclination with VP will be seen in the top view. So draw a line inclined to VP at 30 degrees. On this line you take this edge. So measure B and C and take it here. Suppose this is B and this is C. So take it on the line which is inclined to VP at 30 degrees. Now you have satisfied the VP condition. Now redraw this top view, not this top view. You have to redraw this top view in this position, okay, because you are fulfilling both the conditions, HP condition and as well as VP condition. So measure AB and AC will be same. So with AB as radius, B as center, draw an arc. With C as center, cut that arc. You will get the point A. You can take the point A on this side also. You can draw the arcs here and take it on this side. No problem. Then join A and B and A and C. So this will complete the top view of the lamina, whose side opposite to the corner is inclined to VP at 30 degrees. Now project the front view. How to project the front view? Draw the projectors from A, B and C. You know A is on the XY line. So draw the projector, vertical projector till XY line. This will be A dash. B is above the XY line. Draw the vertical projector from here, and from the previous front view, draw a horizontal projector to cut that. So this will be your new B dash, and from C, draw the vertical projector. You know B and C are B dash and C dash are on the same line, so this will be C dash. So if you join A, B and C, A dash, B dash and C dash, this will give you the front view of the lamina. Okay, so this completes the projection of a lamina which is resting on HP on one of its corners. The edge opposite to the corner is inclined to VP, the surface is inclined to HP. So the similar type of problems you will get for pentagonal lamina, square lamina and hexagonal lamina. Okay, so these are the problems. That is problem number 17, 18, 19, 20, 21, 22 from the notes, from my notes. Okay, so this is one type of problems which you get in lamina, which is when it is resting on its corner on HP. Another type of problems you will get is what he will say. Suppose if you draw them, if you join this corner to the midpoint of this edge, it is called as the median. It is called as the median, as you have done for hexagonal lamina. Oh, sorry, as you have done for when the lamina is resting on HP. So here the median passing through the corner. This is the median passing through the corner. What we will say is the lamina is resting on its corner on HP. The surface is inclined to HP, and the median passing through the corner on which the lamina is resting on HP is now it is parallel to VP. So he says it will be inclined to VP like this, or it can be like this. So you can see when I lift the lamina like this, the median also gets lifted. So the median will be inclined to HP. Then again he is saying it is inclined to VP. So you know that if you consider the median to be a line, the line when it is inclined to HP and VP, you will not see the true inclination or true length of the line either in the top view and in the front view. Okay, so I'll teach you how to solve such problems. So we'll consider this triangular lamina itself. For example, he says a triangular lamina, okay, is resting on one of its corners on HP. One of its corners on HP. Next, he can say the surface is inclined to HP at say 40 degrees, okay, or then this is the HP condition, and the median passing through the corner on which the lamina is resting on HP is inclined to VP. So at 30 degrees. So you may get this type of problems. Okay, this problem can be also stated like this. So this is one wordings which you can use to describe the problem. Another type of wording says a triangular equilateral triangular lamina is resting on one of its corners on HP such that, I will write here, such that the median passing through the corner on which the lamina is resting on HP is inclined to HP at 40 degrees and to VP at 30 degrees. Draw the projections. So both these sentences mean the same thing. Both these mean the same thing. As I said, see, if in the first case he says the surface is inclined to HP at 40 degrees, okay, and you can see the median is also inclined to HP at 40 degrees, okay, and he says the median is inclined to VP at 30 degrees. Here it is, the median is inclined to VP at 30 degrees. So in both cases, it means the you will get the same meaning. There will be only one solution. Okay, he may ask you in this form or in this form. Okay, please be careful. You can go through the problems which are given in my notes as well as in the video question bank. Okay, that is if you have that. Okay, now I'll teach you how to draw the projections of such a lamina. Okay, so here this will be the XY line. Start from the top view, as you know, because the lamina is resting on HP. So draw the equilateral triangle such that the line joining the center and the corner should be parallel to VP. So this is A, B and C. So draw the median now passing through the corner. So median is the line joining the corner and the center midpoint of B and C. So this is the median. We'll call this as M. Okay. Now draw the front view. Front view will be a line on the XY line. So this will be the front view of the lamina. So if you look from here, A and B are only visible. This is A dash, B dash, and C dash will be invisible. C is invisible, C dash will be invisible, as well as M. If you consider M also will be invisible. So this will be the initial position. Next is the HP condition. The surface is inclined to HP at 40 degrees. So always I told you in the front view the corner A will always be on the XY line. Now draw a line inclined at 40 degrees. What must be the length of this line? It must be equal to A dash and B dash here. So measure A dash and B dash and mark it off here. So this will be the new front view. So this will be B dash and C dash and M dash. So the median is inclined now to HP at 40 degrees. The surface of the lamina is also inclined to HP at 40 degrees. It is one and the same, as you can see. Now next project the top view. Draw the vertical projector from here and from the previous front top view. Draw a horizontal projector. You will get A. Okay. Then from B and C, draw the vertical projector, and from B previous top view, draw a horizontal projector. From C also you draw a horizontal projector. You will get the points B and C. Join A, B and C. Okay, then M. From M, draw a horizontal projector. This I'll call it as M1. Okay, we'll call this as M1 because you can see this length has been shortened here. Okay, this is the true length of the median and this is the apparent length of the median because the surface or the median is inclined to HP. So in the top view you will see a shorter length line. Okay, next step is very important. This is called as the HP condition. Next step is important. He says the median passing through the corner on which the lamina is resting on HP is inclined to VP at 30 degrees. So this median is inclined to VP at 30 degrees. So what you do, you draw the line inclined to VP at 30 degrees. So this is true inclination with VP. Okay, draw a line which is inclined to XY line at 30 degrees. Next, because it is true inclination with VP, you have to first take the true length of the median. That is, AM is the true length of the median. On this line, you take A and M. Measure the length from here and take A and M. Suppose this is A, okay, and this is M. Okay, Now next is, all these are construction lines, they must be thin lines. Next, draw the locus of M. Next, measure the apparent length of the median, that is AM1. With this AM1 as radius, with A as center, cut the locus. This will be M1. Join AM. This will be the new position of the median when it is inclined to VP at 30 degrees. So if you extend this and measure this angle, this will be your beta. It will be greater than 30 degrees. Now draw this top view in this position. How? You know this median is perpendicular to BC. So from M1, draw a line perpendicular to AM1, perpendicular to this. Okay. Then from M1, measure the distance M1B and M1C. Both will be same. So measure this distance M1B. Okay. You mark it on one side. This will be your new B, and mark it on the other side. This will be C. Okay. Join ABC. This will be the new top view in the VP condition when you have fulfilled the VP condition. So project the front view. How to project the front view? Just draw the projectors from A, B and C. You know A is on the XY line. So draw the projector up to XY line. This will be A dash. B is above the XY line. Draw the vertical projector from B. And from the previous front view, draw a horizontal projector. This will be B dash. And C dash, again B and C are in the same line. So draw the vertical projector from C to cut the horizontal line which you have drawn from C. So this will be C dash. Join A dash, B dash and C dash. This will complete the solution. Okay. So similar problems you will get for pentagonal lamina as well as square lamina. Okay. So as I said, please try to solve the problems which I have given. Okay, and submit it by 10th. So on 11th you will be having the unit test on projection of lines and planes. Okay, thank you.